So now I'm going to show you the part B of exercise 6 that we started earlier. So the first thing I'm going to do, I'm going to define my complementary solution, and then I'm going to check it to see if it's correct. So what was the complementary solution? Well, if you remember, we wrote that the complementary solution was C1 times the vector 1, 1, all multiplied by the cosine of 2 times t, so 2 times t. And then we had minus another vector, minus -2 and 0, all multiplied by the sine of 2 times t. And then we had the second term, c2, all multiplied by -2, 0, times the cosine of 2 times t, plus the vector 1, 1, times the sine of 2 times t. And then we don't want it to output, so I put a semicolon here. And let's check for a second. Let's check for a second that we wrote everything correctly. So C1 times 1, 1 cosine of 2t minus -2, 0 times sine of 2t plus C2 times -2, 0 cosine of 2t plus 1. Here, I made a little bit of a mistake. There it is. 1, 1 sine of 2t. Now that I have this, I'm going to define my coefficient matrix. So the coefficient matrix was, if you remember, -1, -1. So -1, -1, -1. Well, you need to write it in rows. So -1, 5 was the first row. The second row was -1 and 1. And I don't want this to output. I'm going to define my forcing function, which was the part that made it non-homogeneous and that I labeled as f of t. And that was the sine of t in the first row and -2 times the cosine of t in the second row. And I don't want this to output either. Now, checking the homogeneous solution, what we want to do is we want to write, here we want to write the derivative of xc, and we want to see if that is equal to a multiplied by xc. Now notice how I don't have the f of t here because this is the solution just to the homogeneous. I want it to output, so I don't put a semicolon, I press Control Enter, and MATLAB is saying, hey, I don't know what C1 is. So one thing we have to do is defining the variables. And the variables are defined by the command sims, and they are C1, C2, and T in our case. So now we press Control Enter again, and we see, and we want to see whether we get the same thing on the left-hand side and on the right-hand side. And if we don't, then we assume that we made a mistake. So I don't see the same stuff on the left and on the right completely. Let's try one more thing. Let's try to simplify, or to expand first and then simplify. And we'll do it to both sides. So here, expand, simplify. What do we get here? Well, we get S1 is equal to S1, and the same thing on the left is equal on the right. So it was hard to look at it, but doing this allows us to be sure that this is a solution that is working, so that we did it correctly. Now, let's think about what our guess was. So our guess had other variables. It had a1, a2, b1, b2. So we add those to the declared variables, and then we're going to say defining the particular solution guess. And that's, we're going to call it x of p. And what is that going to be? Well, what we said earlier, it's a1, b1 times the cosine of t plus a2, b2 times the sine of t. Okay, well, we don't have any repetitions here because cosines of t is not the same thing as cosine of 2t, so they're linearly independent. So we can use this guess. I'm going to put a semicolon because I don't want it to output. And now I'm going to find the coefficients. And to do that, we need to input x of p back into this expression. Back into this expression. However, now we need to add the forcing function. So we have a times xp plus f of t. And let's try to tell it to expand and simplify. So I need two parentheses here, and here I still have it in the copy and paste. We press Control Enter, and what we see here we see we're getting an error here. I don't really know what's going on. So let's take that out and let's just write diff xp, that's the derivative of p with respect to t, I'll specify it, and that has to be equal to a times xp plus f of t. And if we do that, what do we get? See if we get another mistake. Nope. We get this stuff right here. Well, this number looks pretty interesting, doesn't it? So let's see if we're able to change to asking for MATLAB for decimals. So that's format short. And then we do it again. If we don't make careless mistakes like that, spelling mistake here, it still gives me a fraction. And that's a pretty nasty fraction, isn't it? So 2 in here instead of a t. So I was getting a value here instead of this. Well, now that we have this, I'm gonna create, I'm gonna match the coefficient. And remember, we have 4 unknowns, so we need 4 equations. So let's look at all the coefficients of cosines at the top. So we only have a1 on the left, and then negative a2 plus 5 times b2 plus 5 times b1. No, 5 times b1 is with the sign, so that's it. We have negative a2 and plus 5 times b2. And then we're going to look at the coefficients of the sign, so negative a2, and that's going to be equal to what? Is going to be equal to 1 minus a1 plus 5 times b1. And then we're going to look at the bottom, the coefficients of the cosines once again. It's going to be b1 is equal to b2 minus a2 minus 2. And then the coefficients of the sine, minus b2 is equal to negative a1 plus b1. Okay, so let's just check. B1 negative A1 B negative B2, okay. Then negative 2 negative A2 B2 B1, 5B1 negative A1 1. So here I see 5B1 negative A1 1 negative A2, and here I have A1 negative A2 plus 5B2. Now I have 4 equations, so I'm confident I can solve for 4 unknowns with the solve function. So solve here, and I'm gonna solve for A1, A2, B1, B2, and I'm gonna rename those A1s, A2 variables. So A1, A2, B1, B2. And then rewriting the particular solution. So solution, we're gonna have xp of t. Well, since I rewrote it with the same variable names, I can just do this, and I'll output it so that I don't want to output this as long as it's right. I'll output this, and then checking my particular solution to check if it's right. So I'm going to take the derivative of x of p of t, and I'm going to make that equal to a times x of p. So I don't even need to write of t. I just write x of p plus f, and I'll do simplify after I expand, and the same here. I'll do simplify after I expand. And now I press Control Enter, and here it's telling me the wrong use of the operator here because I copied the whole thing. So that's how I want to do it. Press Control Enter, and we're going to go down the line. Now it has found our values, and here we see that the left hand side is equal to the right hand side, so we know that that is equal. So I'm going to define the whole general solution. I don't need to write whole, just the general solution, and that's going to be x of t, and it's going to be the sum of x of c of t plus x of p of t. And since both of these worked alone, we don't need to check them together. However, if you want to check the general solution, maybe for a typo or something, you can write the same thing. So simplify after expanding the derivative of x, and here a times x plus f, and again I want to simplify after I expand it. Expand right here. So we press Control Enter once again. It's not the most efficient way because it reruns the whole program. And now I wrote expanding and I wanted to do expand. So I'll fix that. This is our general solution. And I need a simplify. There you go. Simplify, expand, simplify, expand. This is our general solution, and now we're checking that it is correct. So we just want to check that we get the same thing on the left and on the right. We see here, the top one's the same, bottom looks the same as well, so we're confident that we have the right answer. I hope this was useful, and I will see you next time.